Okay, so we're going to do exercise 9B, question 1A, where we're going to construct a payment schedule for annuity in the growth phase. So the question is asking us to create a payment schedule for the following annuities in growth phase, showing 5 deposits. So I've already set up the table here with the 5 deposit phase stages, and it's set up exactly like in the textbook. So it tells us we have an initial balance of $50,000. So we're going to put this here because at the beginning, when time is 0, we have that balance of $50,000. We haven't deposited anything yet, we haven't earned any interest, and we haven't got a principal increase either. Now at the first, remember we're looking at recurrence relations. So at the first phase, we are looking at interest of 3.2% per annum. The question is telling us that it's compounded quarterly. So we will need to work out I with deposit, and we have deposits of $4,000 per quarter. So we can actually put, for the 5 amounts, the $4,000 straight away into our table, because each quarter we are depositing $4,000. Now let's have a look at the interest that we've got. So I is going to equal the interest rate, 3.2, divided by 100 to turn it into a decimal, multiplied by 4, because remember it's quarterly, so it's 4 times per year. Put that into our calculator, and we will find 3.2 divided by 100 times 4 is 0.008. So that's our interest rate. So now we can actually work out the interest on this annuity to start with. So it's just going to be by the $50,000, which is $400. So therefore the principal increase is going to be $4,000 plus $400. And we add that to the balance of our annuity. So $50,000 plus $4,400, and it equals $54,400. Now, so that was for the first compounding period, the first quarter. The interest rate is remaining the same, the deposit is remaining the same, but the interest that we earn is now actually on the new balance of the annuity. So we can just multiply 0.008 by this new balance, 54400, and we get 435.20, and we need to add that to our $4,000, the amount that we're depositing each quarter. And the new balance is 4435.2. So therefore the principal increase, we then add that to the most recent balance of the annuity, and we get 58835.20. So we just keep repeating this. So we've got this amount here, and we need to figure out, multiply it by 0.008 again to figure out the new amount of interest. And as you can see, the amount of interest that we're earning is increasing because we're earning interest on an increasing balance. So the principal increase, let's add that again. So we add the interest to the deposit amount, and we're now adding 4,470.68 to our previous balance here, 58835.20. 542, and it's going to be 6330588. Again, we now work out the new interest based on the more recent balance, just multiply it by 008, and it's now 506.45. We'll round that. We need to add that to the 4,000, so it's now 4,506.45, and we need to add that to the previous balance of the annuity, 63305.88. So now after 4 quarters we have 67812.33, and the last phase for the 5th one, same again. Firstly we work out the interest, which in this case is 542.50. We add it to the deposit, which it makes it 4542.50, and then we add that to the balance of the previous annuity, 7812.33 and 72,354.82. So we've answered the question here. We've got our initial balance of 50,000. We're earning 3.2% per annum, which is 0.008 as our interest rate in a decimal per quarter. We're compounding it quarterly with our $4,000 each quarter, and we have found that our answer is 72,354.82, which is quite a tidy increase from 50,000 at the start.